There was a time that I made a video on Zealot S78, and I made mention of the capacity of the battery on the speaker, that it has two battery. Here is one and here is two. So this is the nylon that I removed here. So each battery, this is 12,000 mAh, and I mentioned that this speaker, that is Zealot S78, as of course you are going to plug the two. That's if one side, one battery is 12,000 mAh, that means the two will give you 24,000 mAh. That is a very big battery. But a person said that Zealot was not accurate with the capacity that they give the battery, that it was not up to. Well, I said, I'm going to find out if that is the case. But now, here is the battery. Here are the batteries that are on Zealot S78. Let me see if I can. Good. So here is the same battery. Okay. Here is the same battery. Look at it. This is 12,000 mAh. What you want to, find out is the capacity. The capacity they claim is 12,000 mAh. Now the question is, does Zealot speaker, that is each bank like this, each battery, does each battery really have this 12,000 mAh? Let's find out. But here's the thing you need to know about cells. Yeah, cells can be arranged in series and can also be arranged in parallel. You understand? For example, as it is here, all these, they are in parallel. You look at all of them, they have flat surface. Okay, look at this. These ones, they are also in parallel. Okay, you see that it has the same, you see, the surface is different from this. All right, now let's turn to this side. You look at this. This, yeah, you see that it's at the same surface, but the surface is different from this, but they are joined together. So as it is, they are in series because positive is joined to the negative. While in parallel, it's going to be the same thing all through. Like this one, they are all in parallel. They are all in parallel. You understand? And the other hand, this side is all in parallel, while this side is all in parallel. But this is joined to this, which now makes the connection between here and here to be in series. But now, here's what you need to know about how to do calculations. So when it comes to cells, there are two things. Number one, as you've noticed here, all right, as you've noticed here, there is voltage, that is PD, potential difference, and there is the capacity, and it's rated in, this is in amp, okay, in amp hour. So if you connect the battery, the cells rather, if you connect these cells in parallel, the capacity of each cell will add up. Let's see, for example, if this one is 2, yeah, let's say 2 amp hour, and this one is 2. So that means as this one is connected in parallel, right? Oh, let me use this so that it's not be confusing. All right, so let me use this because as it is, they are not joined together, right? Good. So 1, 2, 3, right? All of them, they are connected in parallel, right? So 1, 2, 3. So if this one is 2, that means 2 plus 2 plus 2, right? So that will be, the total of this is going to be what? 6 amp hour. So that will be the capacity of this because all this has been joined together. Now the voltage, let's assume the voltage of this is 3. The voltage is going to remain the same. So now, if cells are connected in parallel, the capacity of the cells will increase, but the voltage will remain the same. That is the principle. The voltage will remain the same, but the capacity of the cells will increase. Now, if it is connected in series, as it is now, let's say these cells, they are connected in series. That means instead of the capacity to increase, the capacity will not decrease. The capacity will remain the same, but what will increase is the voltage. You understand? So the voltage is going to increase. So if the voltage is going to, the voltage is going to increase. All right. So Now, you've understood the principle. If it's connected in parallel, the capacity will increase, while the voltage will do what? Will remain the same. But if it's connected in series, if it's connected in series, the capacity will remain the same, but the voltage is going to double. You understand? That is it. In parallel, voltage remains the same, but the capacity increases. But in series, the capacity remains the same, but the voltage double. The voltage increases. Good. So now let's come to this. Now look at here. Let's look at each of these. This cell is called lithium ion. This is Li. So this is lithium. Ly. This is lithium. Yeah. So this cell is called lithium ion. And this 18650. What does it mean? This 18 shows the width, that is the diameter of this cell. So each cell has diameter of 18 mm. Then 65 is the length of the cell. So that means the length of this cell, if you use a meter to measure it, is going to give 65 mm, right? So that is 1865. And this 0 is saying that this cell, it is cylindrical. This is 0. So 0 is cylindrical. So that the cell is cylindrical, okay, in shape. So it is a standard, right? So the last one is talking about the shape of the cell. So that one is about the dimension, the first one. This 2000 mAh, that's milliamp hour, this tells the capacity of each cell, right? And this 3C, this C means that is the rate of discharge of this cell. 1C that is 2000 mAh. So 3C means that is 3 times 2 will give you 6000. That is 6000 mAh. In other words, that will be 6 amp. So that means each cell can discharge, like at a go, it can discharge like 6 amp of current at once. So this is the 3C. It's talking about the capacity of the discharge capacity of the cell. Right, that is the C. Why this one is 3.7 volt? This is the nominal voltage of this cell. Yeah, nominal voltage. So when it is fully charged, it can charge up to 4.2 volts. And it can discharge up to 2.5. But if it's less than 2.5, it can damage the cell. All right. So now you've understood this. Now, the capacity of each cell is 2000 mAh. This is what we want to use. 2000 mAh. Now let's look at how this thing is arranged. If you look at, you see that, let's try to break this to 2, although it's connected. You see that these are joined, but these are not joined together, right? So like now, so let's assume, use your mind's eye, let's cut this and this. You see that they are separated. You see that all the positive they are connected and all the negative are connected. So as it is, this side is 1, 2, 3. This side is connected in what? In parallel. So that means, remember, each cell is 2000 mAh. That means 1, 2, 3. That means all these 3, they have what? What is it? That is going to be 6000, right? If each cell is 2000, 2000 times 3, that will give you 6000 mAh. So that means all this is 6000 mAh. But now, Zealot is saying that it's 12,000 mAh. So if this battery is 12,000 mAh, that means all these cells, all of them will be connected in what? In parallel. But and if all of them are connected in parallel, look at the nominal voltage is 3.7 volts. So that means they cannot achieve this 7.4 volt. The voltage is going to get stuck at 3.7 volts. So for a fact that the voltage goes up to 3.7 volt, that means, of course, it's quite evident. Look at here. Yeah, look at here. See that it's connected in series. This is the negative, right? If you look at the side, it will be indicated. You see this minus. You see that is a flat surface. Good. The other place positive. This is the positive side. You see that the positive side is attached to the negative. Everything here. So that means this side is connected in series to this side. So it doubles the voltage, right? It doubles the voltage. So as it doubles the, that means this bank here attached to here in series doubles the voltage. So it will be wrong to also add the mAh to this place because it's connected in series. You are not going to add the capacity. No. So that means we only use one side of the capacity. So in summary now, so what have we find out? Zealot plus all the cells together, despite the fact that all the cells are not connected in parallel. Just only 3 are connected in parallel. While we have this other 3 connected in parallel, but this one is connected in series to it in order to double the voltage. So that means that one of these is off. Yeah, one of this is off because it's connected in series. We can't add it. So instead of 12,000 mAh, the right capacity is 6,000 mAh. It is never 12,000 mAh. So this is 6,000 mAh, right? So being that it is true, so that will be 12,000 mAh. So that means on Zealot S78 speaker, the capacity of the battery that is on the speaker is 12,000 mAh, the total. While each one, as this one is 12,000 mAh, no, it is not. It is 6,000 mAh, right? 6,000 mAh. Then, and this 7.4 volt here, I'm sure it's going to be more than, because if each, look at here, each is 3.7 volts. And 3.7 volt connected in series will give you what? That's 3.7 times 2. Will give you what voltage? Is that not 7.4? Yeah, this 7 times 2, that is 14. Yeah, 7.4. And remember, this is a nominal voltage. If this cell is fully charged, it should increase up to 4.2 volts. So now with 4.2 volts times 2, so that will give you, is that not 8.4 volts? So that means when this battery is fully charged, it should give you 8.4 volts. So it's higher than this. And if they use nominal voltage here, it's happened they use the nominal voltage actually. Yes, they use it. This is 7.4 volts, so that is nominal voltage. 3.7 times 2. 3.7 times 2 will give you 7.4 volts. So that is the nominal voltage there. Look at it. Yeah, connected in series. So if they multiply it because it's connected in series, so why did they multiply the decimal as well? No, they are wrong. So this is 6,000 mAh, right? 6,000 mAh. The voltage is correct. This is the nominal voltage. Remember, this voltage can get to 8 points. Is that not 4? Yeah, because 4.2 volts to when it's fully charged, so times 2, that is 8.4 volts. So 7.4 volts can get to 8.4 volts. That is additional of 1 volt. So that is it. Now, is Zealot speaker 12,000 mAh? Never. It is 6,000 mAh. So for the combine, like this, as this one is the same thing available to this, all this. So the two combined is 12,000 mAh, while one is 6,000 mAh. All right. So that is, the comprehensive review about Zealot S78 Bluetooth speaker battery.